Hello, my name's Chris Albertson. I'd like to welcome you to my VLAN and Trunks video, and I hopefully be able to keep this under half an hour. So let's get to it. So what we want to cover today is why you'd want to use a VLAN, the differences between static, dynamic VLANs, local end-to-end VLANs, how to create VLANs, how to configure your switch to give access to VLANs to particular switch ports, how to set up trunks to trunk your VLANs, different types of encapsulation that's used on your trunks, how to view your VLAN settings through various commands, and how to view your trunk interfaces and the commands used to do that. And then we'll go over dynamic trunking protocol, the different modes of operation there, trunk, dynamic, desirable, dynamic, auto, and no negotiate, and the encapsulation used on trunks again. So why would you want to use VLANs? Well, a VLAN allows you to overcome the limitations of a flat network topology. A flat network topology is, by definition, a network that is on a single broadcast domain, has no layer 3 divisions segregating traffic, just one big flat layer 2 broadcast domain. There's no ability to load balance or use redundant paths in a flat network topology. A VLAN will also allow you to segregate your data into virtual networks, and this will limit the PC's ability to access data from other virtual LANs unless there's a layer 3 boundary involved, and it limits the scope of broadcast domains. So this little package tracer illustration I have here is a perfect example of a flat network topology because all of these switches are on one VLAN, which is the default VLAN of 1. All these PCs are connected to access ports on these switches that are all assigned to VLAN 1. So any PC could communicate with any other PC within this network topology. Any broadcast traffic will reach all these PCs within that network topology. That's one giant broadcast domain. Or not giant, but anyways, one broadcast domain here. And if I wanted to split this up and make it a non-flat topology, I would have to assign VLANs and then allow for a layer 3 device to move the traffic from one VLAN, one virtual network, to another virtual network, so that the PCs that are assigned to the different virtual networks could gain access to that data through the layer 3 device. So there's two methods of assigning switch ports access to a VLAN. That would be through a static method, where we would go and manually configure that switch port to have access to only one VLAN, or to dynamically assign a switch port to membership of a VLAN with a VLAN membership policy server, which basically will identify the host's MAC address plugged into that port, communicate with the VMPS, and then assign that switch port membership to a VLAN based on the MAC address of the host that has been connected. So let's go ahead and on this 2950 I have here, and we'll go ahead and configure some VLANs and assign switch ports statically and dynamically. This is a fresh boot. I'm going to turn off console logging here, so we don't want to see that. Now the default VLANs on a Catalyst switch are VLANs 1, 1002 through 1005. These cannot be edited or deleted in any way. By default, all these switches are connected to VLAN 1. Actually, Fast Ethernet 01 is also, but for some reason it is not here because it's got a trunk on it. But by default, all of these are have access to switch port, or VLAN 1. I went ahead and disconnected that cable there that was forming our trunk. And now we see we have Fast Ethernet 01 on assigned to VLAN 1. Now if we want to take and create more VLANs to move these switch ports into other virtual networks, we would do this in such a way. We could use a VLAN command with the VLAN number, and that creates the VLAN. Right here we see we have our VLAN 10 with a name of VLAN 0010, but this is not very descriptive, is it? So we'll go back to VLAN 10 and we'll set the name to admin. And we'll create a VLAN 20 and we'll call it research. And we'll do a VLAN 30. Now you see here our VLAN 10 has been named to admin and our VLAN 20 has been named to research. Now if we ever want to delete any of these VLANs, let's say we're going to delete VLAN 30 here, we can go no VLAN 30. And we now see VLAN 30 is gone. If we do no VLAN 1002, we cannot delete that. Because like I said, the default VLANs, which are 1 and 1002 through 1005, cannot be changed or deleted in any. Now, as I had said, a switch port can be either statically given a membership to a VLAN or dynamically done so. And remember, static, we have to manually configure a switch port to have access to that VLAN. So what we'll do is we'll go ahead and take switch ports 2 through 8 and assign them to VLAN 10. Oh, we're already in configuration mode. Interface range. Fast Ethernet 0, 2 through 8. So I want that hit the equals key by accident. And now we're going to go, oops, sorry. Switch port mode access. And what we're doing here is we're telling that range of interfaces that they are going to be only accessing one VLAN, statically accessing, and we're going to tell that those interfaces that they only have access to VLAN 20 or 10. I'm sorry. Now if we go back here, we see that VLAN 10 is now assigned to interfaces Fast Ethernet 02 through 08. And let's do the same for VLAN 20. We'll go 9 through 12. Now let's say, for instance, we wish to have some of these interfaces to be dynamically assigned. So we would use that with the dynamic switch port command. And we would basically go, let's go ahead and assign switch ports 13 through 15 dynamically. Through 15. Oops, sorry. remote access, switch port, access, VLAN, dynamic. So basically, 13 and 15 aren't showing up here because they haven't actually been assigned any VLANs, because it's dynamically done, and like I said, it's based on MAC address. In order to use that functionality, we would actually have to configure a VMPS server. Actually, we're not configuring a server, we're configuring the access to the server. We would have to set up the server, and we'd have to give it the IP address to the server, and we'd have to identify that as the primary server. And then we can set up a secondary server, which we identify by leaving out the primary switch there. And we can see here that we now have configured the IP addresses to our servers, and we basically every hour, once a PC has been validated access to a VLAN based on its MAC address to a switch port, every 60 seconds or every 60 minutes that will be revalidated, and we'll have 3 attempts to connect to a server before that will fail. We can change those settings with the reconfirm command, which sets the time limit. It could be 0 to 2 hours, so we'll go 15 minutes. So every 15 minutes we'll reconfirm that port. And then let's go ahead and say we want to retry 5 times. Our options are 1 to 10, so 5. And we see our settings are now set. And once again, like I said, 13 through 15 aren't going to show up here until a PC is plugged into one of those ports and the VMPS server validates their MAC address and assigns that port a VLAN based on the host's membership to a VLAN based on its MAC address. So next we want to go over local VLANs and end-to-end VLANs. A local VLAN is basically confined to a geographical location like a building or a floor on a building, whereas a end-to-end VLAN would be across your entire network. A local VLAN does not cross your distribution layer, whereas an end-to-end VLAN will cross your distribution layer. It'll go into your core, into other geographical locations on your network. And local VLANs are much easier to troubleshoot than end-to-end VLANs because the fact that all VLAN traffic is confined to access and distribution layers, and it doesn't go within your core. Now I've got a packet tracer simulation here that could show this really well. This is one building. This is another building. If I was to have the same VLANs in this building as I did in this building, any particular routing loops or broadcast storms that may occur here could go past my distribution switches into the core, across the core, and into this other building. That would be an example of an end-to-end VLAN where broadcast traffic is impacting my entire campus. Really, you don't want to use an end-to-end VLAN unless you have a good reason. One good reason for using an end-to-end VLAN would be for the dynamic assignment of access ports to VLANs based on MAC address of the host. They would have to be able to go anywhere within your campus, hook up to any network cable or any switch, and be able to access the VLAN which they're allowed to access. Now, as soon as we begin to use layer 3 devices to keep keep VLAN traffic confined within this area between our hosts and our access and distribution switches. When we confine that that VLAN traffic here, that becomes a local VLAN. It's no longer end to end. And this particular topology I have here is somewhat inefficient because we actually have VLAN traffic going from our switches in the access layer to the distribution layer into the core, and then from the core it's being routed through this router. Really, to make this as efficient as possible, we would want to have some type of layer 3 devices, probably at the distribution layer, most likely some layer 3 switches that would confine all broadcast traffic, all VLAN traffic to this section of our network. Anything that needed to go outside of this portion of our network would have to go through a layer 3 boundary, through our core, through a layer 3 boundary into the other portions of our network. And that would limit the broadcast storm routing loop issue to this area, making it much easier to troubleshoot. And then let's go ahead and talk about dynamic trunking protocol too. Like I said, there is the 4 modes of dynamic trunking protocol. One was the access mode, which was a no negotiate type thing. The trunk mode, which is a no negotiate. The automatic desirable, which is a negotiated connection, and dynamic auto, which also was a negotiated type connection. When I have a switch with 2 access ports hooked together, they are only able to move data that's assigned to that VLAN on that access port. As soon as I want to start moving more traffic, I have to use a trunk. So a trunk will allow me to move multiple VLANs between switches. When I have a switch port set to trunk mode, let's go ahead and describe the active trunking as exercise. When I have a switch port set to trunk, this guy is only going to trunk. He's going to work out. He's only going to trunk. That's the only thing he's going to do. It doesn't matter what the other side is set to. This switch port is going to trunk. If the other switch port is set to access, it's still going to trunk. It doesn't care. Now, the dynamic desirable, that's the default Cisco mode of dynamic trunking protocol. And basically in this mode, if the other end can trunk, then we're going to trunk. If not, we're not going to trunk. So basically we're going to exercise if the other side is able to exercise, and then we'll exercise. If not, then we won't. If a trunk port is connected to a dynamic desirable port, a trunk will still be formed because this guy is always trunking. This guy will trunk if the other side can trunk, and that would be the case, so a trunk would be formed. 2 dynamic desirable ports hooked together would trunk because they both want to trunk and they both can trunk, so they will. The last type is dynamic auto. It's a passive form of dynamic trunking protocol which will not establish a trunk on its own. So if you have 2 ports set to dynamic auto, a trunk will not be formed. What you know, when you see auto, you're thinking, well, that means it's going to be formed. No, basically it's the lazy guy. It's the 2 bums on a couch that will not motivate each other to get to the gym. Now, if there's a trunk hooked to dynamic auto, then dynamic auto will trunk. And if a dynamic desirable is connected to dynamic auto, a trunk will be formed. The only time a trunk will not be formed is if dynamic auto is connected to another dynamic auto port. No trunk will be formed. It'll remain an access port. So again, just to reiterate, dynamic trunking protocol is used to auto-negotiate trunk links. Now, DTP frames are sent over trunk links every 30 seconds to exchange data on the status of the trunk ports on each end of the cable. The no negotiate option is best used with critical ports because this tells the switch port not to negotiate if there's a trunk involved, and basically you don't negotiate. There's no need to negotiate when you have switch ports set to access or switch ports set to trunk. Trunk is the best mode to be in for critical ports because there is no chance that trunk will become anything other than a trunk because it's set to be a trunk only. Dynamic desirable is the Cisco default, and dynamic auto is the passive form of DTP trunking, DTP protocol, dynamic trunking protocol, trunking. There's no active trunking trying to be done there. So two dynamic auto ports will not create a trunk on their own. Now the types of encapsulation supported are ISL and the IEEE 802.1q standard. Now ISL is a Cisco proprietary protocol which is only supported by Cisco switches. That's why it's proprietary. It encapsulates your frames by adding 26 bytes to the front of the frame and 4 bytes to the end of the frame, which is basically called double tagging. A lot of newer Cisco platforms don't support ISL and favor 802.1q over ISL. Or, yeah, they just don't support it. But if you do have a catalyst switch that does support ISL, and dynamic trunking is used to create your trunk between your two switches, ISL will be used over 802.1q. 802.1q embeds 4 bytes into your frame right after the address field. And this is called single tagging or internal tagging. Now, one feature that 802.1q has over ISL is that it supports a native VLAN. And a native VLAN is basically unencapsulated traffic that's sent over your trunk that can be interpreted by a host. So if you were to take a trunk and hook it to a host PC and it had native VLAN traffic on that trunk, your PC would be able to see that native VLAN traffic as if it was hooked to an access port, and it would be able to access that VLAN as if it was not being trunked. But your host would not be able to identify the encapsulated traffic that the trunk was carrying otherwise. So now let's go back to our switch and we'll go ahead and set up some trunks. If we go show interface trunk, we'll see that there are no trunks currently established. Show interface description. We actually have no active ports on our switch at all. And then if we go look at the running configuration for our fast Ethernet 01, we'll see there's no actual configuration here. But what I've done is I've connected a crossover cable between two switches now. And if I do a show interface trunk, I see that there is now a trunk established. And that was because my mode was in dynamic desirable mode. And I am trunking with 802.1q encapsulation. My native VLAN is 1. And these are the VLANs that are currently being trunked. These are the VLANs that are created on my switch. Now, if I was to change which VLANs can be assigned to my trunk, if I don't want the default behavior of dynamic trunking protocol to trunk all my VLANs, I could limit the VLANs that are going to be trunked. Go to my interface in question. And I'm going to allow it access to, oops. I can say all VLANs, which is the default behavior currently. Or if I want to take VLAN 1 off of that, I can basically say all except VLAN 1. So basically what I'm saying here is all except VLAN 1. And then if I want to remove a VLAN and then another VLAN, so if I go all except 1, and then I go all except 10, basically 1 is going to be re-added to the list, and I'm going to take 10 off because I'm saying all except 1, all except 10. So let's go all except 1. And do a show VLAN trunk, and now I see that I'm trunking 2. I'm potentially going to trunk 2 through 4094. Now, if I show the interface fast Ethernet 01, the switch port option, what we will see here is that we are in dynamic desirable mode. Switch port is enabled. We are trunking with 802.1q encapsulation. Our native VLAN is 1, and we are able to trunk all VLANs from 2 to 4094. Now, if I wanted to change the native VLAN, well, one thing of interest here, you see that we're in access mode VLAN 1, and we're also using native VLAN 1 here. It is possible to set up a switch port to have an access mode, which gives access to a particular port, and a trunk that's going to trunk data. So let's go ahead and create a couple extra VLANs here real quick. Let's go and create a VLAN 30. We'll call it research. Name sales, and VLAN 40. We'll call it office. We have our 4 VLANs there. Now, if I wish to set up a switch port to have native traffic on VLAN 10 and access mode traffic of VLAN 20 and to trunk 30 and 40, I would do it like this. I go config T interface fast Ethernet 01 switch port say native, and we want to say the native VLAN was VLAN 20. And then let's say switch port mode access VLAN 10, and then switch port trunk allowed VLAN 30 and 40. Okay. Let's see how we can do this with the, say we want to remove 1 and we want to remove 10 and 20. Sorry about that. So now if we look at our running configuration for fast Ethernet 01, we can see that we have access to VLAN 10 as an access port. We have native VLAN access to VLAN 20, and we are trunking 2 through 9, 11 through 19, and 21 through 4094. So being that our switch port is in dynamic desirable mode, what this will allow us to do is if there is a host hooked to this port, it will have access to VLAN 10. If another trunk is hooked to this port, it will trunk native VLAN 20 traffic, and it'll also trunk VLANs 30 and 40. Now, by having this in dynamic desirable mode, it pretty much renders this particular option useless. Now, if I was to have the switch port set to trunk mode, then I hook a host to this port, it would be given access to VLAN 20. And let's do a show interface trunk. And we see there we are in dynamic desirable with the 802.1q trunking, native VLAN of 20, and these are the VLANs that are being trunked. And then if I go to switch port interface, fast Ethernet 01, show interface, fast Ethernet 1 switch port, we see that switch port mode is enabled. We're into dynamic desirable. We are trunking. We're using 802.1q. We have our switch port as a possible access to VLAN 10, a native of VLAN 20, and these are the VLANs that are being trunked. VLANs for pruning and BTP and whatnot we'll go over in our next video. So hopefully we'll see you there. But basically, this is it for this particular video. And then again, just to go over what we discussed, we talked about why you'd want a VLAN, the differences between static and dynamic VLANs, local and end-to-end VLANs. We created some VLANs. We configured some switch ports to be an access, static access or dynamic access. We configured some VLAN trunks. We talked about encapsulation. We viewed our VLAN settings and our trunk port settings with various commands. We also discussed dynamic trunking protocol, how trunking is always on, dynamic auto is passive, and then dynamic desirable is the default Cisco default mode of operation. No negotiate would be used to stop the transfer of DTP frames between ports. You might use that with the trunking mode of access or the access mode of access. And again, it's some more on encapsulation. So I always welcome comments. You can find my website here. Go there, and that's my website, and I welcome comments there, and I use that to post up various videos and different content. So hopefully see you there. And the next video is going to be on VLAN trunking protocol, and hopefully you'll see you there. All right, bye-bye.